Welcome to the Language Year, Comprehensible Input for Learners. Today, we're doing a deep dive into something that, well, it might sound a bit intimidating, statistics.
Statistics, yeah.
But stick with us,
Yeah.
because we're going to approach it like detective work, really, using numbers as clues.
That's a great way to put it. I mean, think about it. You see numbers absolutely everywhere.
Right.
Headlines about polls, telling you what voters are thinking, charts showing economic trends, figures about, well, pretty much everything.
Exactly. And when you see those numbers, you wonder, what's really behind them? Like, how did they get that figure? What does it actually mean?
Uh-huh. And instead of just sort of nodding along, we could become data detectives.
I like that, data detective.
Yeah. Statistics is basically the science of learning from data. It's about taking information that's often messy, full of variability, uncertainty.
And finding the story hidden inside.
Precisely. A statistician is, well, kind of like a detective. They gather their clues, that's the data, and use their tools to uncover patterns, figure out the uncertainty, and reveal what the data is trying to tell us.
So it's not just crunching numbers.
Not at all. It's about making sense of the world around us.
Okay, so where do these data detectives even begin? I gather there are like two main types of statistics.
That's right. First up, you've got descriptive statistics.
Descriptive, okay.
This is all about summarizing the data you actually have in front of you, just describing its main features.
Like if a teacher has test scores for her class, say 30 students.
Perfect example. Descriptive statistics helps her summarize that specific group of 30 scores. No guessing about other classes, just describing these ones.
So things like finding the average score, the mean.
Yep, the mean. Or you could find the median score, that's the one exactly in the middle, if you line all the scores up from lowest to highest.
Okay.
And the mode, that's simply the score that pops up most often.
Mean median mode. Got it. But what about, like, were all the scores pretty similar, or were they all over the place?
Good question. That's where standard deviation comes in handy.
Standard deviation? Sounds technical.
It just measures how spread out the scores typically are from the average.
Yeah.
How much they deviate.
So a big standard deviation means the scores were, like, really varied, highs and lows.
Exactly. And a small one means most students scored pretty close to the average. It tells you about the clustering.
Okay, so descriptive stats give you a clear picture of the data you have, like a snapshot.
A snapshot is a good way to think about it.
But the really powerful stuff, the predicting part that comes next, right? Inferential statistics.
Yes, inferential. This is where our detective work gets, well, a bit bolder. It's about using a sample.
A smaller group.
Right, a smaller, hopefully carefully chosen group to make educated guesses or inferences about a much larger population, a population you probably couldn't measure completely.
Like those political polls we see all the time? They talk to maybe, 1,000 people?
Often something like that, yeah. That's the sample.
And then they claim to know what millions of voters across the whole country think. How does that even work?
Well, that's the magic and the challenge of inferential statistics. It definitely involves uncertainty.
Right, because you didn't ask everyone.
Exactly. And that's why probability comes into play. It's the language we use to talk about that uncertainty. How confident can we be in our guess about the whole population based on just our sample? Think of it like tasting soup. You taste one spoonful, that's your sample, to decide if the population needs more salt.
Okay. You don't need to drink the whole pot.
Nope. But crucially, that spoonful you taste, it needs to be representative. Like you need to stir the soup first. Your sample needs to reflect the larger group accurately.
That makes a lot of sense. So you mentioned probability. Is that just like the chance of something happening, like flipping a coin?
Pretty much. The probability of a fair coin landing heads is 0.5 or 50%. It gives us a way to quantify likelihood.
Okay. And I read that numbers often fall into patterns, these distributions, like the bell curve.
Yes, the normal distribution, or bell curve, is super common. Think about human height.
Okay.
Most people are somewhere around the average height. Right? So the curve is highest in the middle.
Yeah.
Fewer people are extremely short and fewer are extremely tall. So the curve slopes down on both sides. It's symmetrical. You see this pattern a lot in nature and even, say, with player heights in a sports league. Like the NBA, most cluster around an average, fewer at the extremes.
And the peak of that bell is usually the average, the middle value, and the most common value all rolled into one.
Often, yes. In a perfect normal distribution, the mean, median, and mode are all right there at the center.
Cool. What about finding connections? Like, do these two things seem related?
Right, that's correlation and regression. Correlation looks at whether two things tend to move together.
Okay.
There's a classic example. In the summer, ice cream sales go up. And unfortunately, so do shark attacks.
Whoa. Wait, does eating ice cream somehow attract sharks?
Huh. No, thankfully not. This is maybe the most important rule in statistics. Correlation does not imply causation.
Ah, okay. Phew.
Just because two things happen together doesn't mean one causes the other. There's usually something else going on.
Like what in the ice cream example?
Hot weather. Hot weather makes people buy more ice cream, and it makes more people go swimming in the ocean, which increases the chance of encountering a shark. The heat is the third factor, the confounding variable.
Gotcha. So correlation just shows a link, a pattern, but not why. You need more detective work for the why.
Exactly. And speaking of detective work, you also need to be aware that numbers can be used to mislead.
Oh, really? How?
Well, especially with graphs and charts, people can get tricky. A really common one is messing with the y-axis, the vertical scale on a graph.
How so?
You might chop off the bottom part of the scale, so maybe the scale starts at 100 instead of 0. This makes tiny little differences look like massive, dramatic jumps or drops.
Like statistical plastic surgery? Makes small things look huge?
Yeah, that's a perfect way to describe it. So the lesson is always, always check the scale on a graph.
Be skeptical, ask questions.
Definitely ask, what's the scale? What are they not showing me? You need to develop your statistical spider sense.
Statistical spider sense. I like it. Okay, so wrapping this up. Statistics helps us make sense of data, right? From summarizing what we have,
To using small samples to understand big populations.
dealing with uncertainty, finding relationships.
And hopefully spotting when someone's trying to pull a fast one with numbers.
And the key thing seems to be you don't have to be a math whiz.
Absolutely not. Being statistically savvy is much more about asking good questions, thinking critically, and just being aware when you see numbers in the news or about health or politics.
It's about clear thinking, about understanding our world, which is just full of data.
You got it.
Yeah.
Statistics is really the science of us.
Well, this has been fascinating. Thanks for joining us on this number detective adventure. Until next time, keep questioning those numbers. This has been the Language Year, comprehensible input for learners.